So dual simplex method is almost similar to simplex method. There is a slight change. The slight change here it is. In simplex method, normally we have the objective function as maximization, all the constraints less than or equal to, and the right hand side positive. But here, the objective function is maximization, right? All the constraints should be less than or equal to, but the right-hand side positive, that condition is not there in dual simplex method. Okay? Screen is not visible. Division B. Is it visible? Division B students? It's visible, no? Okay. ठीक है, तो डिफरेंस यहाँ पे ये है कि सिंप्लेक्स मेथड में ऑब्जेक्टिव फंक्शन मैक्सिमाइजेशन है, यहाँ पे भी सेम है, कंस्ट्रेंट्स लेस देन और इक्वल टू दोनों जगह सेम है. वहां पे कंडीशन था कि राइट हैंड साइड पॉजिटिव है, बट डुअल सिंप्लेक्स मेथड में दैट इज not the restriction that the right hand side should be positive. So here the right hand side can be negative, only thing the objective function has to be less than or equal to. Okay. First example. Use dual simplex method to solve minimize z equal to 3x1 plus x2 subject to x1 plus x2 greater than or equal to 1, 2x1 plus 3x2 greater than or equal to 2, and x1, x2 greater than or equal to 0. So again, they will specify the method that dual simplex. It can be solved by big M method. As it is, if you see, it can be solved by big M method also. But here we are going to solve by dual simplex method. So the first condition is objective function should be maximization. Objective function should be maximization. All the constraints should be less than or equal to. Objective function should be maximization and all the constraints should be less than or equal to. So converting this minimization problem to maximization, we will get maximization of minus z, or actually it is z star, we can write minus 3x1 minus x2 subject to, we are converting these constraints to less than or equal to, so minus x1 minus x2 less than or equal to minus 1, minus 2x1 minus 3x2 less than or equal to minus 2, and x1 x2 greater than or equal to 0. So normally what type of variables are added to these constraints when we have less than or equal to constraint? कौन सा वेरिएबल हमको ऐड करना होता है जब लेस देन और इक्वल टू कंस्ट्रेंट रहते हैं? Slack variable. Now, as there are two constraints, we will add two slack variables, S1 and S2. So adding two slack variables, S1 and S2, and reducing the, rewriting this equation again with the cost 0, 0. We are giving the cost as 0, 0, writing S1 equal to minus 1, S2 equal to minus 1. So there is no condition that the right-hand side is positive. You can have right-hand side to be negative in this case. Okay? तो पहला कंडीशन है कि अगर डुअल सिंप्लेक्स है तो ऑब्जेक्टिव फंक्शन मैक्सिमाइजेशन कंस्ट्रेंट्स लेस देन और इक्वल टू, and right hand side there is no condition that it has to be positive or any other number. But if you have a simplex method, there also we have objective function maximization constraints less than or equal to, but the right hand side has to be positive to apply simplex method. In dual simplex method, even if it is negative, we can apply the dual simplex method. Okay, so same way we'll form the table. Everything is same. Again, the procedure remains the same. जितने variables हैं उसको लिखना है x1, x2, s1, s2 and bi's. Then what are x1, x2? सबसे पहले first constraint लेंगे तो minus 1, minus 1, 1, 0, minus 1. Second constraint का है minus 2, minus 3, 0, 1, minus 2. Same as what we have done till now. Then Cj. Cj क्या होता है? Minus 3, minus 1, 0, 0. Then XB column. XB column, we have 1, 0, 0, 1. These 1, 0, 0, 1 is corresponding to the variable S1, S2. Cost of these variables 0, 0. Zj's are what? 0 into minus 1 plus 0. Same as what we were doing for big M method, simplex method. Everything is the same. 0 into minus 1, 0 into minus 2, that is 0. सब 0 हो जाएगा यहाँ पे, zj minus cj. So 3, 1, 0, 0. So now here what you will find in dual simplex method, all zj's minus cj's are positive. All zj's minus cj's are positive, but bi's are negative. When we write s1 s2 greater than or equal to 0, इसका मतलब है कि s1 की वैल्यू पॉजिटिव आनी चाहिए थी, बट वी आर हैविंग s1 bi's to be negative and all zj minus cj's to be positive. In the simplex method, we had bi's positive and all zj minus cj's were negative or 0 or positive. है ना? फर्स्ट स्टेप में वहां पे क्या होता था, ये पॉजिटिव रहता था, बी आईज यूज टू बी पॉजिटिव एंड दीज यूज टू बी आइदर नेगेटिव और पॉजिटिव और 0. तो यहाँ पे ये सब पॉजिटिव है एंड बी आईज में नेगेटिव है, सो चूज द मोस्ट नेगेटिव बी आई. वहां पे हम लोग मोस्ट नेगेटिव zj माइनस cj चूज करते थे. इन ड्यूअल सिंप्लेक्स मेथड चूज द मोस्ट नेगेटिव bi's. So most negative bi is out of -1 and -2, we have the most negative as -2. So this row will become the key row. सेकेंड रो जो है वो की रो हो जाता है. ठीक है, वहां पे हम लोग पहले हम लोग की कॉलम निकालते थे, फिर रेशियो निकालने के बाद की रो निकालते थे. इन ड्यूअल सिंप्लेक्स मेथड पहले हमको रो निकालना है. रो कैसे निकालना है? बाय चूजिंग द मोस्ट नेगेटिव नंबर इन द बी आई कॉलम. उसके बाद यहाँ पे भी रेशियो लेना है. यहाँ पे मैक्सिमम रेशियो है. इन सिंप्लेक्स मेथड वी हैड मिनिमम रेशियो. In dual simplex method, we have maximum ratio and the ratios are taken only for negative numbers. There we used to take ratios only for positive numbers. In this dual simplex method, ratios are taken for negative numbers. तो जितने भी की रो में नेगेटिव नंबर्स हैं उसका रेशियो निकालना है इसके साथ. So the first ratio हो जाएगा 3/-2. ठीक है, की रो जो है हमारा सेकेंड रो है. सेकेंड रो में दो नंबर्स नेगेटिव है, तो जो भी नंबर्स नेगेटिव है उसके करस्पॉन्डिंग zj माइनस cj देखना है अपने को, एंड देन zj माइनस cj अपॉन द करस्पॉन्डिंग नेगेटिव नंबर. तो इसका आंसर हो जाता है -1.5. फिर इसका लेना है, इसका हो जाएगा 1/-3, दैट इज इक्वल टू -0.33. ना यहाँ पे मैक्सिमम रेशियो, तो दोनों में से बड़ा कौन सा नंबर है? मैक्सिमम रेशियो. choose the maximum ratio. There we used to choose the minimum ratio. Now we have to take the maximum ratio. तो कौन सा बड़ा है दोनों में से? -1.5 और -0.33 में कौन सा नंबर बड़ा है विथ नेगेटिव साइन? -0.33. मतलब ये वाला जो कॉलम है -0.33 वाला, दिस कॉलम विल बिकम द की कॉलम. And the intersection of key row and key column, the intersection of key row and key column, this will become our key element. Okay, this will become our key element. So what we have done, same table we have written, and when you write the table in the dual simplex method, bi's will be negative and zj minus cj's will be all positive or 0. And then since bi's are negative, you have to choose the most negative bi. So most negative number out of -1, -2 is -2. The second row becomes the key row. Then in the key row, look for negative numbers. In the key row, look for only negative numbers. If there are positive or 0, don't consider that for the ratio. Whichever numbers are negative, take the ratio of zj minus cj upon the corresponding negative number in that key row. So 3/-2, 1/-3, दोनों का रेशियो निकाला. मैक्सिमम रेशियो हमको निकालना है, तो मैक्सिमम नंबर इज, और द ग्रेटर नंबर इज -0.33. So this column becomes the key column. Intersection of key row and key column becomes the key element. Okay, so we have the key element. अभी हमको क्या करना है, जैसा हम लोग करते थे, की एलिमेंट को 1 करना है बाय डिवाइडिंग द सेकेंड रो बाय -3 एंड देन यूज रो ट्रांसफॉर्मेशंस टू मेक द रिमेनिंग एलिमेंट 0 till all the bi's becomes positive and zj minus cj's are also positive or 0. Till that we have to continue this procedure. Any doubt in this procedure? Anybody having any confusion here? Division A, please unmute yourself and ask if you have any confusion, if you have any doubt. No doubt? Clear? तो हमें क्या करना है, सेम टेबल फॉर्म करना है जैसे हम सिंप्लेक्स का बनाते हैं. उसके बाद यू विल फाइंड दैट बीआईज आर नेगेटिव बट जेड माइनस सीजेस आर पॉजिटिव और जीरो. तो सिंस बीआईज आर नेगेटिव, चूज द मोस्ट नेगेटिव बीआई. अगर ये पॉजिटिव है और ये नेगेटिव है तो वी हैव टू चूज द मोस्ट नेगेटिव जेड माइनस सीजे. So since BI's are negative, we are choosing the most negative number, that is -2. Second row becomes the key row, and C for the negative elements in the key row. So we have -2 and -3 as the negative numbers in the whole row. So we have to take the ratio of Zj minus Cj upon the corresponding negative numbers in the key row. And the maximum ratio will become the key column. So correspondingly, -3 will become the key element. Now divide the second row by -3 and rewrite the table again. Again, in the next table, we can cancel Cj row, we can cancel Cb column and Zj row. So in the next table, I'm dividing only this step. I'm doing it in the next table. Dividing the second row by -3. तो ये हो जाएगा 2/3, ये हो जाएगा 1, ये हो जाएगा 0, ये हो जाएगा -1/3, and this will become 2/3. So in the next step, I've got 2/3, 1, 0, -1/3, and 2/3. Rest all the things are same. So I've cancelled that Cj column, Cb column, and Zj row. Now use the row transformation. This is the key element. Hai na? This is the key element. So use this key element, make these two elements 0. तो यहाँ पे कुछ m नहीं आएगा, कुछ नहीं आएगा. It is same as your simplex method, only it's a reverse of that. In simplex method, we choose the most negative Zj minus Cj, and in the in the dual simplex method, we choose the most negative BIs. That is only the difference. और दोनों negative नहीं आएगा. You will not have Zj minus Cj is also negative and Bi is also negative. दोनों नहीं आएगा. So either Zj's will be negative or Bi's will be negative. Whichever is negative, choose the most negative number. ठीक है? So now the row transformations will be R1 plus R2 and R3 minus R2. R1 plus R2, R3 minus R2. So writing the second row, write the second row है 2/3, 1, 0, -1/3 and 2/3. Tell me the first row. First element क्या होगा? -1 plus 2/3. कितना हो गया? -1 plus 2/3 is how much? -1/3 or 1/3? -1/3. Then -1 plus 1, that is 0. 1 plus 0, that is 1. 0 minus 1/3 is -1/3, and -1 plus 2/3, again you will have 1/3. Is it minus or plus here? This part also? ये भी माइनस आएगा ना फिर? I think हाँ, okay, माइनस है यहाँ पे. ठीक है, minus sign is there. So the XB column will become now, okay, the last row. Last row is 3 minus 2/3. 3 minus 2/3 will become 9 minus 2/3, which is 7/3. 1 minus 1 is 0. 0 minus 0, 1/3. So next we have to write the XB column. In the XB column, we have two variables, S1 and X2. X1 and S1 and X2. Again, we are having one BI is negative. All Zj minus Cj's are positive or 0, but we have one BI negative. So choose the most negative. We have only one option. That is the first row. That becomes the key row. In the key row, see for the negative elements. There are two negative elements, -1/3 and -1/3 here. So take the ratio of 7 by 3 upon minus 1 by 3. Zj minus Cj upon the corresponding negative number. Zj minus Cj upon the corresponding negative number, which is equal to minus 7. This is positive, this is 0, this is positive, this is negative number. So take the ratio of 1 by 3 upon minus 1 by 3, which is equal to minus 1. So now which one is the key column? -7 होगा कि -1 होगा? S2 wala rahi. Yes. Why it is S2? Because -1 is greater than -7. We have to take the maximum ratio. In the simplex method, we have minimum ratio. In dual simplex method, we have maximum ratio. So this is equal to -1. So now this becomes the key column. Now the key element will be equal to this part. Hai na? This is the key element. -1 by 3. That is the key element. So again, making the key element 1 by dividing the first row by -1 by 3 and making all the remaining elements in that column 0, and then check for again BIs and Zj minus Cj. ठीक है? Procedure is the same in simplex, big M, or duality, or dual simplex method. And there is one common mistake what we find is when the dual simplex method is asked, so many students, what they do is they calculate the dual and then find the solution. It is not that. Dual simplex is different, duality is different. When they ask use duality, then you have to find the dual and then solve the dual and find the solution. But when they ask dual simplex, you don't have to calculate the dual. You have to just convert this to maximization and less than or equal to constraint and solve by the normal method. So don't confuse between these two methods. Duality है तो dual निकाल के solve करना है और dual simplex हमको directly solve करना है. Okay. So in the next step, now what I will do is making the key element 1 by dividing the entire row by -1 by 3. Okay. -1 by 3 divided, I'll get this table. Rest all the rows are same. So only this was the change. है ना? तो ये अपना की एलिमेंट था. अभी ये दो एलिमेंट्स को जीरो करना है. तो इसको जीरो करने के लिए R2 + 1 by 3 R1 और इसको जीरो करने के लिए R3 - 1 by 2 R2. So R2 + 1 by 3 R1, R3 - 1 by 3 R2. So first row will remain the same. 1, 0, -3, 1 and 1. Tell me what will be the second row. Second row में what you have to do is R2 + 1 by 3 R1. 2 by 3 + 1 by 3 into 1. So 2 by 3 + 1 by 3 हो जाएगा. -1 by 3. What is that, Harsh? -1 by 3 R1 मतलब? That is R2 is na? R2 is R2 plus 1 by 3 आएगा ना यहाँ पे. R2 plus, because this is minus. So when you multiply by 1 by 3 and then add. Okay, when we add, we will get the answer as 0. So it's -1 by plus 1 by 3, right? Second one. Second one is -1 by 3. Okay. So what is the first element? That is, we've got 1. 2 by 3 plus 1 by 3 becomes 1. 1 plus 0, that is 1. -3 into 1 by 3 is -1. 0. 2 by 3 plus 1 by 3, that is equal to 1. Then the third row is R3 - 1 by 3 R2. So 7 by 3 - 1 by 3. 7 by 3 - 1 by 3 is 6 by 3. That is 2. 0, 1, 0. ठीक है? So which columns are there? Which variables are there in the XB column? Which variables are there in the XB column? S2 and X2. Yes, S2 and X2. Now we can see that all BIs are positive, all ZJ minus CJs are positive. So we have reached the final table, which means we can write the solution from the final table. So what is the solution? Now we have to look for the variables in the basis. The given variables were x1, x2. We are having only x2 variable in the basis, which means that the x1 value will be equal to 0, x2 value will be equal to 1, and the value of z can be calculated by using the objective function. So 3x1 plus x2, 3 into 0 plus 1 equal to 1. Okay? Clear? Any doubt in this? Same procedure, only thing, objective function is maximization, constraints less than or equal to, and then here we will find that all Zj minus Cjs are positive, but Bi is negative. So choose the most negative Bi. We will get the key row. Once we get the key row, look for negative elements in the key row. And once you have negative elements, divide Zj minus Cj upon the corresponding negative elements, and then find the maximum ratio, get the key column. Intersection of key row and key column is the key element, and then make the key element 1. Continue this process till you get all BIs positive and ZJ minus CJs positive. If you have any doubt, you can ask. Otherwise, I'll move to the next problem. सेम है, कुछ भी फर्क नहीं है जो हमने अभी तक किया है. खाली that method choosing the ratio and the most negative number, यही वही यहाँ पे change है, बाकी everything is the same. Yeah, division A, if you have any doubt, you can ask. Anybody? Okay, so we'll move to the next problem. Minimize z equal to x1 plus x2 subject to 2x1 plus x2 greater than or equal to 2 minus x1 minus x2 greater than or equal to 1, x1, x2 greater than or equal to 0. We have to solve by dual simplex method. So convert the objective function to maximization and all the constraints to less than or equal to. So converting the object, since the given objective function is minimization, converting the minimization problem to maximization and converting these constraints to less than or equal to. So we can rewrite the equation, maximize z equal to, you can get a z star maybe for a change. That is, we have taken, because z is actually minus z in the case of maximization here. So minus x1 minus x2 subject to minus 2x1 minus x2 less than or equal to minus 2, x1 plus x2 less than or equal to minus 1, x1, x2 greater than or equal to 0. How are we converting this greater than or equal to less than or equal to constraint? By multiplying both the sides of these constraints by minus 1. So when you multiply an inequality by minus sign, the inequality gets reversed. Now there are two constraints, so we have to add two slack variables, S1 and S2, giving the cost as 0 in the objective function. So minus x1 minus x2 plus 0 s1 plus 0 s2 minus 2x1 minus x2 plus s1. Okay? So what we are doing is, first we are converting the objective function from minimization to maximization, converting all the constraints to less than or equal to by multiplying by minus sign and then adding slack variables. So now we'll form the table, the initial basic table. So I'll rewrite this again in the next slide. Yeah. So there are four variables totally. Two variables given in the problem and two variables we have added as a slack variables. So x1, x2, s1, s2 and bi. x1, x2, s1, s2 and bi. Writing the variables minus, writing the coefficients of the variables, minus 2, minus 1, 1, 0, minus 2. सेकेंड कंस्ट्रेंट से अगर लिखा तो 1, 1, 0, 1, -1. CJs. CJs are the coefficients of all the variables from the objective function. -1, -1, 0, 0. Then we have to write the XB column. XB column corresponding to this unit matrix 1, 0, 0, 1. That is 1, 0 is corresponding to S1, S2, 0, 1 is 0, 1 corresponds to S2, CB will become 0, 0. ZJs will be all 0 in the basic first table because it is 0 into -2 plus 0 into 1. Then ZJ minus CJ. 1, 1, 0, 0. So here also we find that all ZJs minus CJs are positive or 1 and there are BIs which are negative. So again choosing the most negative. Most negative का मतलब क्या होता है? Without the negative sign, whichever is greater. Without the negative sign, बिना negative sign के जो number बड़ा है उसको बोलते हैं most negative number. So now -2 is the most negative number. So we have got the key row. Once you get the key row, so this is the key row. We have got this as the key row. Once you get the key row, look for the negative numbers. So -2 and -1. There are two negative numbers, -2 and -1. So take the ratio of ZJ upon the negative numbers in the key column. तो पहला आ जाएगा 1 upon -2 which is -0.5 and यहाँ पे हो जाएगा 1 upon -1 which is -1. Whichever is having the maximum ratio, जो maximum है, that is with the negative sign, whichever is maximum, that will enter the, or that will become the key column. So -0.5 is greater than -1. So we can write the first row of X1 column as the key column. X1 column as the key column. And the intersection of key column and the key row. So this is our key column. So intersection of key row, this is called as the key element. -2 is the key element. So next step will be, we have to make the key element 1 by dividing the entire row by -2. So in the next table, again, I'll cancel CJ, CB and ZJ. Even this is not required in the next table because once you apply the row transformation, then we have to see the BIs and then we have to calculate the that is the maximum ratio and all those things. तो हमें फर्स्ट रो को -2 से डिवाइड करना है, तो ये हो जाएगा 1, ये हो जाएगा 1/2, -1/2, 0 and 1. Okay? I'll get this after dividing the, this is the key element, है ना? This is the key element. We have to make this element 1. We have to make these two elements 0 by using this element 1. We have to make these two elements 0 by using this element 1. So R2 minus R1, R3 minus R1. ठीक है, पहले रो को हमने -2 से डिवाइड करके ऐसे ही लिख दिया, बाकी दो रोज सेम लिखे हैं हमने. उसके बाद first row again remains the same. So tell me what is the second row? R2 minus R1. Second row को first row से subtract करना है, तो 1 minus 1, 0. 1 minus half, half. 0 minus of -1/2, 1/2. 1 minus 0, 1. Minus 1 plus 1, -1 minus 1, that is -2. Third row, R3 minus R1. 1 minus 1, 0. 1 minus half, half. 0. ठीक है? So XB column, X1 and S2. Again, we have ZJ minus CJ is positive or 0, but we have one BI is negative. Okay, we have one bi negative, so second row enters the basis, or second row becomes the key row. Second row is the key row. But when we find that, when we want to find out the negative elements in the key row, there are no negative elements in the key row. All the numbers are either positive or zero. We are not having any negative number, which means we cannot take the ratio. अगर यहाँ पे negative numbers है ही नहीं, तो we cannot take the ratio. रेशियो किसका लेना है? जब यहाँ पे नेगेटिव नंबर्स होते हैं. So as there are no negative numbers, we cannot proceed further by taking the ratio, and still we have bi's to be negative also. यहाँ पे negative भी नहीं होना चाहिए, which means that this maximum ratio we cannot take. So this LPP has an unbounded solution. When you are not able to calculate the ratio, minimum होने दो या maximum होने दो in simplex or dual simplex, then the LPP has an unbounded solution. ठीक है, LPP has an unbounded solution. Any doubt? तो just 2 or 3 types हमको देखने कौन कौन से type के हैं. Mostly unbounded, and then normal it has a solution. And in the case of big M method, we have pseudo optimum solution and unbounded solutions. Unbounded कब आता है? जब we are not able to take the ratio, minimum हो या maximum हो. जब ratio लेने के पास रेशियो लेने के लिए हमारे पास जब ये नहीं आते, एलिमेंट्स नहीं रहते हैं वहां पे, then it has an unbounded solution. ठीक है. See again this table ना, if you don't want, you can write it directly, you can do that. मतलब यहाँ पे हम लोग रो कॉलम करके लिख सकते हैं. But I am just showing you this step. This step also you can skip in the exam. Like if you can do directly this step from here, you do that. No problem in that. And in Kumbhojkar, what they have done, a slightly different method. They have done minimization and all those things. So I have not, I have converted all the problems to maximization. Okay, different books have different methods. What is my method is I convert all the objective function to maximization and then have the common procedure for all these things. ठीक है? So don't confuse when you see the Kumbhojkar book. Kumbhojkar ने पूरा अलग अलग method बताया उन्होंने. Follow only one method. Don't mix both the methods. Next problem. Minimize z equal to 2x1 plus x2 subject to 3x1 plus x2 greater than or equal to 3, 4x1 plus 3x2 greater than or equal to 6, x1 plus 2x2 less than or equal to 3, x1, x2 greater than or equal to 0. Converting the objective function to maximization, all the constraints to less than or equal to. यहाँ पे third constraint is already less than or equal to. We need not change that. Only first and second constraints are to be converted to less than or equal to constraint. Again, यहाँ पे z star लिख सकते, नहीं लिखा तो भी चलता है. But if possible, write this as z star. यहाँ पे एक star डाल सकते हैं. Just to show that the star is minus z actually. जो भी हमारा z दिया था उसको हमने माइनस करके यहाँ पे लिखा है, तो we can take it as z star. If we don't take it's fine. But if you remember, write z star as the function. ठीक है. थर्ड कंस्ट्रेंट को हमने चेंज नहीं किया है because it is already less than or equal to constraint. Again, adding slack. There are 3 constraints, so we have to add 3 slack variables, S1, S2, and S3. So adding slack variables S1, S2, S3 to the constraints. So in simplex, in dual simplex method, there is no artificial variable. Okay, we have everything slack variables only. Only in the case of big M method, where we have greater than or equal to constraint and equality constraint, we have to add artificial variable because we are subtracting a surplus variable. Here we are adding a slack variable. Even these two steps can be written together, like converting minimization to maximization constraints, and then you can add slack variable simultaneously. Okay, these two also we can have only one step. I have shown both the steps. That is not required because the problems are a little bit lengthy. It's time consuming. So you have to find time how to complete the problem. Because it's normally 8 marks questions, but if it is asked for 5 marks, it's going to take time. Yeah. So forming the table with the help of these LPP, the variables x1, x2, s1, s2, s3 and bi's. जितने भी variables हैं, we write all the variables in the table. Then the coefficients of x1, x2, s1, s2, s3 from the first constraint. यहाँ से coefficient लिखना है. First वाले constraint से coefficient. So -3, I'm sorry, -3, -1, 1, S2 is not there, S3 is not there, BI is -3. फिर सेकेंड में से है ना, सेकेंड कंस्ट्रेंट में से हमको x1, x2, s1, s2 वगैरह लिखना है. तो -4, -3, 0, 1, 0, -6. फिर थर्ड में से है ना, थर्ड में से we have to find we have to write the coefficients. So x1, 2, 0, 0, 1, 3. Then next we have to write is Cj. Cj's are the coefficients of from this function. है ना? So Cj's are 2, -2, -1, 0, 0, 0. XB column. S1, S2, S3. And S1, S2, S3 corresponding cost is 0. तो CB भी हो जाएगा 0. Zj will be, I'm repeating again, 0 into -3 plus 0 into -4 plus 0 into 1. तो यहाँ पे हो जाएगा 0, 0, 0, 0, 0. Zj minus Cj, 2, 1, 0, 0. Choose the most negative. Now all Zj minus Cj's are positive or 0. Choose the most negative Zj minus Cj. So -3 or 3 में ही choose. This part is already positive. तो -3 और -6 में most negative हो जाएगा -6. The second row becomes the key row. In the key row, you have to see for this is the key row. We have to see for the negative numbers. So this is negative, this is negative. So take the ratios of Zj minus Cj. 2 upon -4, that is -1 by 2 or -0.5. And 1 upon -3 is -0.33. तो कौन सा बड़ा है इसमें? और ये कौन सा की कॉलम होगा? -0.5. यहाँ पे मिस्टेक नहीं होना है कि इट्स अ मैक्सिमम रेशियो. So -0.5 and -0.33. -0.33 is the maximum. This becomes the key column. तो ये वाला हो गया key column. Now intersection of key row and key column. This is called as the key element. -3 is the key element. Again, repeat the procedure. Making the key element 1 by dividing the second row by -3. बाकी सब सेम है, खाली यहीं पे चेंज है. जो हमने अभी तक किया है वही प्रोसीजर फॉलो करना है. चेंज खाली इतना है कि हमको मोस्ट नेगेटिव बीआईस निकालने हैं और रेशियो यहां से निकालना है और मैक्सिमम रेशियो है. So dividing by -3, I will get the first row. कौन सा की एलिमेंट था हमारा? This was the key element, है ना? This was the key element. We have divided by -3, so we got this as the key element. Now make other elements in that row, in that column 0. So -1 plus R1 plus R2, R3 minus 2 R2, R4 minus R2. Writing the पहले सेकेंड कॉलम लिखते हैं. Then R2, R1 plus R2. R1 plus R2 is minus 3 plus 4 by 3. Minus 3 plus 4 by 3 is minus 5 by 3. 0, 1, minus 1 by 3, 0. That is 1. Minus 1, sorry. Then third row, 4, 5 by 3, 1 minus 2 by 1 minus 2 into 4 by 3. So minus 5 by 3, 2 minus 2, 0, 0 minus 0, 0, 0 minus 2 by 3, that is 2 by 3 here, 1 and then 1. Last row, R4 minus R2. So 2 minus 4 by 3, 2 by 3, 0, 0, 1 by 3, 0. Still we have one negative number here. Okay, still we are having one negative number. So this becomes the key row. Sorry, variables are S1 and X2 and S3. This is the key row. Key row may see for the negative numbers. So there are two negative numbers. One is this, other one is this. So choose the ratio, take the ratio of 2 by 3 upon minus 5 by 3 equal to 2 by minus 5, minus 0.4. Then 1 by 3 upon minus 1 by 3 minus 1. Maximum ratio corresponds to this number. So this enters the basis, or x1 becomes the column, key column. And minus 5 by 3 is the key row. Key element. Minus 5 by 3 is the key element. Okay, this is the key element. So make the key element 1 by dividing the first row by minus 5 by 3. Dividing the first row by minus 5 by 3. We have this as the column. This is the table. So this was the key element. है ना? तो अभी ये तीनों को 0 करना है. So R2 minus 4 by 3 R1, R3 plus 5 by 3 R1, R4 minus 2 by 3 R1. So I have not given the animation over here. Just change the second row, third row and the fourth row. And just check the values whether it's right or not. So second row क्या करना है? R2 minus 4 by 3 R1. So this is 0, 1 minus 0, 0 minus 4 by 3 into 3 by 5. That becomes 4 by 5. Next is minus 1 by 3, minus 4 by 3 into 1. Just check these values, whether these only has to be checked. And last BI's value. If it is right, then we have got all BI's positives. The J minus CJs are also positive. So we have got the final solution. Please check the values, okay? Check the second row first. Check second row, third row, and the fourth row. I have got the book answer. Just check whether these values are right or not. Is it okay? Second row बराबर है? Second row and the third row. Also the fourth row. So once we get all BI's positive and ZJ minus CJ's positive, we can write the final solution. ZJ minus CJ is greater than or equal to 0, BI's. So we will have X1, this is a variable X1 here. X1 is 3 by 5 here. and x2 is 6 by 5. Okay, substituting everything in the z variable. If there are any mistakes, please let me know so that I can correct it over here. Otherwise, with this, we have completed the module, next the LPP module. So we will start in the next lecture by nonlinear programming problem. So we have 4 methods we have studied here. One is the simplex method, big M method, duality, and dual simplex method. So 4 methods are there in LPP. So normally 2 methods are asked in the exam. Okay, any of the 2 methods are asked in the exam. So mostly if it is simplex is asked, then they might ask duality, or they may ask duality and big M. It can be anything. Two, sometimes simplex and dual simplex also they ask. Any 2 methods will be asked in the exam. Okay, so I think we'll stop for today. If you have any doubt, you can ask. A division, any doubt? I'm not able to see A division chat. That is why I'm asking. Third BI is 2.